Thanks, Harry. Good morning, everyone. We have a great set of talks lined up today, but we also have with us several people who can shed light on many aspects of marine robotics. We have a great panel here, and we put up some questions on Pigeonhole for people to be able to vote or add their own questions, and there seem to be a bunch of burning questions that are already on the Pigeonhole that I'm going to start them off with. But we will hopefully have enough time to open the floor to some questions along the way as well. So before we start off with the questions, let me briefly introduce the panelists, and I'm going to get them to say a little bit about themselves. So we have 4 panelists. We have Richard Mills, who is the Director of Marine Robotics Sales with Kongsberg Maritime. He's in charge of several of the underwater vehicles at Kongsberg Maritime, and he can tell us a little bit about himself in a minute. Then we have Fausto Ferreira, who is at the Center for Maritime Research and Experimentation in Italy. He's been involved with the European marine robotics competitions, and he also works on regulatory issues around autonomous surface vehicles. We then have Kelly Cooper, who is a program officer with the Office of Naval Research. She has initiated several different student competitions, including the Maritime Robotics Challenge, RoboBoat, Sea Perch, and has been involved with competitions for a number of years now. And then we have Bill Kirkwood, who certainly doesn't need an introduction at SAUVC. He's been around for the last many years. He is with the Monterey Bay Aquarium Research Institute, MBARI, in the US, and has been in charge of development of several vehicles and instrumentations over the years. But if I can have 4 of you to talk a little bit about yourself, that would be wonderful.
Good morning, everybody. Thank you for the opportunity to be here. So, as introduced, my name is Richard, and I'm with Kongsberg Maritime. We're a Norwegian company, but we've got offices in about 30 countries around the world. In total, we're about 15,000 employees, so we're a pretty big organization. We do an awful lot of things, including marine robotics, unmanned surface vehicles, autonomous underwater vehicles. And if you look at the number of vehicles that we've built, we are the world's largest manufacturer. We built something like 650 of these machines that have been deployed on defense, academic, scientific, and commercial operations. So my background, I've been with the company for about 7 years. Before that, I worked for a Canadian company in a similar role, autonomous underwater vehicles and sales. And before that, I did something very different. I was in the military. Thank you.
Good morning, everyone. I'm Fausto Ferreira. I work at the Center for Maritime Research and Experimentation in Italy. I've been there for the past 4 years and a half. Before I was doing my PhD in real-time mosaicing for underwater robotics. And now I'm dealing mostly with competitions, and my newest line of research is regulations for autonomous surface vehicles. Although I'm an engineer and I have a PhD in robotics, I did a bachelor in political science, so I mixed background. It's a bit strange, but I hope it gets a nice contribution for this talk.
Good morning, my name is Kelly. I am from the U.S. Office of Naval Research. I'm very happy to be here and very delighted that Benu gave me an invitation. I think it was payback for the invitation I gave him. And he worked very hard as a judge at robotics in Hawaii. It's nice to see so many familiar faces on the student teams that participate in several of the competitions that I get to manage. So thank you for being here today. My background is as an ocean engineer, an undergrad from Florida Atlantic University, and they worked on the development and especially the modular systems for a number of the underwater systems that Kongsberg works with today. And many of those systems from 20 years ago are still in use at CMRE. Last year when I visited, I was quite happy to see some of them still being used. And the other aspect of my job is I look at developing infrastructure and research capacity and partnerships and networks where the best and the brightest are developing the newest things. And so competitions are an excellent way to meet new people that you wouldn't know from other nations. And I'm very happy to be involved in this one. Thank you.
What are we saying that's new this year? Yeah, I've been coming to this competition since it started as part of the IEEE OES, which is a great organization, by the way. I'll take a moment here. You end up making friends all around the world and connecting. So through IEEE, I met Kelly, of course, all the team here in Singapore, the guys in Italy. So I can't stress enough that creating a network is important to your career, particularly when you're young. So if you're not a member as a student of OES, you should really consider that. On the professional side, I've been in a lot of things. I never trained to be in marine business at all. So it came about through other things. I was actually in the industrial military complex and just wanted to work close to home, so I switched. I've been at Embari now for about 30 years. So I know there's going to be a question here coming up about careers. There always is. So we'll talk about that in a minute. Get going here.
Perfect. Thanks, Bill. With that, the first question is indeed about careers, but it is nice that we have a very diverse panel, so we should get different perspectives from the industry, from research organizations, both on the military side as well as the non-military side, and from the government aspect of things. So the first question, which is the burning questions with the highest vote, is what career opportunities are available in underwater robotics?
Well, there are a lot of possibilities. It depends what you're interested in. Even though there's a lot of possibilities, the actual field of marine robotics and so forth is kind of a tight community. So when I go to trade shows or conferences and so forth, we pretty much know each other. So you guys are going to replace us. So I'm going to retire in a few years. So Ralph is replacing me here. So, but don't be worried too much about it being just robotics. There's lots of other things you can do with your engineering degree that are very interesting. So I've actually built more instruments than I have robots. So, and I'll talk about one of them later. There's other places to go also. So, like I said, I did aircraft and space vehicles. Using that knowledge, I got into the underwater business. So if you're solid with your engineering, you're going to be fine in your career. Don't worry about that. If you really want to work on the ocean, oil and gas is probably the biggest area, I would believe. If you really want to do mechatronics, I'm an adjunct at Santa Clara University, and so I've got a lot of students there. You know, the academic path can be quite rewarding also. It doesn't pay the best, by the way. So, the first time I taught a class, I made less money per hour than they did flipping burgers at McDonald's, which I did do. But there's all kinds of things. Like I had a student at Santa Clara. I got him actually to France for 2 years working on a chemical CO2 enrichment project for looking at ocean acidification. He came back to the U.S. and now he's one of the lead engineers at the Dragon space capsule. So had a whole marine career thing going with me. Came back, couldn't find a job right away, so now he's in space. So I wouldn't worry too much. Just focus on your engineering and be good.
If I may. So one of the advantages you all have, having competed in such a competition, is that you've created a team, which is essentially like starting a small business. You had to, organize yourselves. You had to decide who was leading, which technical direction. You had to raise funds. You had to consider logistics to get here. You had to ship your vehicle. So you have a lot of inherent knowledge just by your participation in this competition outside of the technical aspect. Don't sell that experience short. Make sure you highlight that on your resume. That will make you stand out from other people applying for the same job, that your experience level is not only technical, it's practical. The other thing is that I would encourage you to stay in school to get a master's degree. And then I would encourage you to work in a technical field for some time. I did that. I got a master's degree in systems engineering from Johns Hopkins University. And I went to work at a research lab in the United States. And from that, gained the experience required to then become a program officer. And I have to say, I think I have the best job in the world. I get to travel around. I get to make decisions about what technology to invest in. And that's very rewarding to see something spark and emerge, to recognize it, to provide some funding or fairy dust to help mature that and grow that, and then see that become a viable product in the marketplace, whether it's for military application or industrial commercial application. So my advice to you is to stay in school, do as many internships as you can along that path, and then work in a technical field before you try to move into a management position. That's a solid career path.
Well, I have a shorter career than my fellow panelists, but what I can tell you from my path is that when I finished my master, I got a job in a different country. And in the beginning, I was not sure if I wanted to go for a PhD or not, so I did 2 years of pool research, and then I said, okay, I want to do a PhD. So if you are not sure, I agree that you should continue to masters, but then don't feel the pressure of doing a PhD to stay in academia. You can try something more technical if you are not comfortable, and you can follow that path without doing a PhD if you do not go to academia. All paths are open to everyone, and it's not because you have a PhD that you can get a better job. There's no relation like that, so don't feel pressure to follow that path. The other thing is that don't be afraid of change or slightly adapt to what the current market is or what's your interest on at a certain point of your career. And finally, as Kelly was saying, the advantage of being in a competition is not only the logistics part and the team building and all soft skills, is also the practical experience that you gain here that will be useful for you in sea trials in the future, which might lack your fellow colleagues at the university right now. So I think that's the point that you should also highlight in your resume.
I'm going to say 3 different things. The first one about the industry, the second about my experience, and the third thing about the company I work for. The first thing about this industry is it's continually evolving. What we do today is very different from what we did 5 years ago, and what we do in 5 years' time will be very different again. It's evolving, it's growing, and it's very small at the moment in the grand scheme of things. You know, we're not on the scale of Boeing building hundreds of aircraft a year and employing hundreds of thousands of people in one site as an industry. However, it's perhaps the fastest growing robotics and exploration industry on the planet. So keep that in mind, that there are going to be opportunities in the future. But my experience, I came into this industry relatively late, in my mid-30s. Prior to that, I did something very, very different. I was a military aviator, and I'm not an engineer by trade. So you guys have got a head start already, because you're studying that, or you've already studied that. The one thing about my experience that I think is important, and for you guys to hopefully take on board, is don't be blinkered. And when I say that, I mean don't think that you can only stay in one place and do one thing forever. So my career has taken me all around the world. I've lived in 4 or 5 different countries. I've experienced different cultures and different ways of doing business, from a defense perspective, from an academic perspective, and from a very commercial perspective as well. And it's been thoroughly enjoyable. So please, make sure that your eyes are open and you're looking at the wider horizon, because there are opportunities that might be just around the corner or a little further afield than you're comfortable looking at. I think it was Richard Branson said that if you're offered a job and you don't know how to do it, just say yes, learn tomorrow, and go for it. The final thing I'll say about the company I work for, we are a multinational company. We have, thankfully, one resource for careers information. Kongsberg.com, www.kongsberg.com. I'll put a link on the presentation I'm going to show later on. We currently have something like 70 job applications or job positions open for software developers, mechanical engineers, electrical engineers, all around the world. So that's our biggest resource, and that's the biggest thing I can throw at you guys.
Thanks. Well, Richard, while you're at it, from an industry perspective, what value do you think competitions like this or the ones that are held in Europe or US bring to the table? Do you find this to be valuable from an industry perspective?
Certainly, I mean, both from a personal experience and also from a corporate experience, you know, we look at events like this to see what you guys are achieving. The thing that's astounded me in the last couple of days, this is actually the first AUV competition that I've come and spent 3 days at. And the thing that's astounded me is the complexity of the machines that you've built. So from an industrial perspective, from a manufacturer's perspective, that's impressive. Those are the skills, those are the things we're looking for. The second thing is the different ways that the teams that you guys have gone around solving some of the challenges. Flexibility in approach for a technical solution is incredibly important. We're always looking for that. You know, Bill's going to take this the wrong way. He's been in the industry for 30 odd years. And sometimes, not Bill, sometimes it's people who've been in the industry for a long time get a bit blinkered. And they've done it this way, and that's the only way they want to do it. So what we look for as an industry, as a world leader in the manufacture of AUVs, is we look for the ability to think slightly differently, to look at different ways of achieving a task. Now the one thing that is consistent across all of that is not the experience of physically solving that task, but the experience of being able to source different solutions. So that's the biggest thing that we take away from this kind of competition. You guys have given yourselves a real kind of head start compared to perhaps some of your colleagues at university who aren't participating in this type of thing. As an employer, we look for that industrial participation, that competition participation, to show that you're committed, to show that you're interested, to show that you're flexible, and to show that you're willing to put yourself out there and take a chance.
Bill, you have something to add?
I think the other thing that the competitions do is you actually round out a set of skills that the universities usually miss because getting through the program is just so condensed. So one of the problems I have with my university teaching students is how to solve a problem when it breaks. So you go in the water, it doesn't operate the way you did, and so fault analysis, those kinds of skills you build together as a team, and you don't get that in school anymore. So that's a really big skill. To know it's turning left when you said right. It's like, okay, something happened. So a lot of people don't get that activity. They know about it, but they don't know how to fix it. So I put that out there that it's the hands-on bit where you're working together, shoulder to shoulder, under the gun, and you got to do some analysis real quick to make something work. And I saw almost all the teams having that go on. And by the way, don't feel bad. Every competition does this. Every single one. So, but.
Sorry, can I just add to that? Not only every competition, every vehicle we put in the water when we build it, every single vehicle that we put in the water when we build it has something fail. Okay, and that's from the world's leading manufacturer. So don't feel bad if your machines didn't work on the first time you put them in the water.
Yeah, these are all one-offs. So the other thing I would add, just real quickly too, and I saw it with a lot of you guys, it was awesome, is have some pride in what you're doing. So Richard alluded that I was not one of those blind-eared guys, and I'm happy you said that. I hope you're not lying. But I take some risks. So if you go on the web and you look up the Tiburon ROV, you'll see that it's not a box running around the water. So I started my career in the ocean making things different than everybody else. And a lot of you guys here know about my flying vehicle right now. It's quite different than everybody else's flying vehicle. So to have some pride, take some style into it and whatnot, and then and just be able to defend why you did it. But I don't see any reason why you can't make it look pretty cool.
Bill, while you're at it, and Kelly, I'll have a question for you in a moment, but I have a question that kind of follows on from what Bill said. So you talk about how you saw some of the teams working together to solve some of the problems that they saw. But one of the big questions that I see on the pigeonhole is, do you have any tips for the teams to debug problems that they see at the moment? What is the general approach that they should take to debug problems?
Debug problems. From a systems engineering thing, and by the way, I think That's another area that's quite weak in most engineering schools. So Kelly's degree, in my mind, is actually a really big deal. That's where I find most vehicles really struggle, understanding the system and how everything integrates. If you understand that, and you've got it sort of where the team knows how the mechanicals interact, the electricals interacts with the software, when you have a problem, and I've seen this actually, I saw this in Piombino, the problem was not the software, it was actually an instrument that had a problem. Some water got in the connector, if I remember correctly. And there was the team last year from Bath. Right? So there's some physical fundamentals they didn't have. So, but we fixed that, right? We helped them out and got that going. So I think that understanding your system is the best way to debug things. And if you're a good systems engineer, you're going to have a long career and be quite successful.
Starting up these competitions, and what do you think is the best way to reach out to schools and universities to get students involved?
So I was first invited by Tom Curtin to be a judge at what is now RoboSub. And I was struck at that competition that there were maybe 15 teams, and the teams were largely made up of a collection of computer scientists and electrical engineers. And there was very little concern for the mechanical aspects of it or mechanical integration. They certainly didn't know Bernoulli from bathwater. They didn't have to know hull form, or propulsion efficiency or power density, because nothing in that competition drove considerations toward those design considerations. And so it was less a systems engineering thinking. And I spoke with Daryl from the AUVSI Foundation, RoboNation now, about creating a surface vessel competition, which is now RoboBoat, because I thought that would bring in more of the naval architecture and ship design aspects into the competition, and it has. But it's been detrimental because students have to spend so much time on the design of the vessel that we saw early on. They designed a wonderful vessel, had done powering and resistance curves in their towing tank, and got in the water, and none of their electrical systems worked, and they didn't get away from the gate. So bringing Robot X, that led me to thinking about Robot X, is that we want multi-domains and multi-systems working together, and we can do that and add design elements, but have one vehicle that the students don't have to design, but they augment the design. And that then allows them to focus on the autonomy and the system integration. So that's how I progressed through the competitions. We also started, and sort of giving away my speech for this afternoon, my presentation, but looking at the pipeline of students in the lower grades to become interested in robotics, create a sense of awareness about it through a remotely operated vehicle program called CPERCH. And that has expanded to hundreds of thousands of students in the US and worldwide. And I think as a first exposure, students have a hands-on activity that's pretty easy, but it has the challenge of the maritime and in-water environment. And if they like that, then we have directional arrows where you can move on and do the mate competition and do these other autonomous vehicle competitions. We've also worked very hard to put together teams of subject matter experts to make it easy for new teams joining these competitions to become proficient enough to feel pride in their performance and not feel that they can't come in and compete with Cornell and FIFU and the higher performing Bumblebee teams. And so we look to do everything we can to build avenues for students to improve their performance and learn, and while they're having fun doing it.
So we have in the panel, we have a couple of people from the US, we have a couple of people from Europe. And this naturally brings this question about what do you think of the research that's going on in Asia or the student involvement in Asia in marine robotics as compared to what's happening in Europe and in US? Because often the perception people have, just like what you said, Kelly, that you have teams like maybe Connell and the top-end teams and the teams who don't have that experience worry about how they're going to compete. It's often also the case that people feel the same about Asia versus Europe and US. So what are your thoughts on that?
A good idea can come from anywhere. And I find that if you work with people who consider themselves, in air quotes, an underdog, they think differently and they approach a problem differently. One of the things I really like about this competition is you don't tell people how to solve the problem. You say, here is a task, and whatever constraints you're working under, come up with a solution. And no matter what the solution is, if you are successful, it earns the same number of points, regardless if the solution is keep it simple, or if it's very elegant and elaborate and expensive. So I applaud that. And I think that if you work across many cultures, US, European, Asian cultures, and bring those together, you create something that is better than you could individually. One of my favorite quotes is, the thing you cannot do, no matter how intelligent you are or how well-intentioned, is to make a list of those things that would not occur to you. Now, as simplistic as that sounds, it is the argument for crowdsourcing. And if we only crowdsource with one chain of thought, we haven't truly crowdsourced. And I think that the Asian culture, the Asian education system brings a completely different thought process and good ideas.
So I've been to national competition to US, and we organized in Europe for the past 6-7 years competitions. And although I saw different performances and different types of teams, I liked a lot of experience here, and I think the teams in Asia were very, very motivated. They put a lot of effort. You could see that in the water, and you could see that sometimes not the end result that matters; it's the process in it. And I like it a lot to see how the teams interacted, how they put effort, and how they were happy to do what they tried to do at least, or even how they were happy to try, even if they couldn't make it. They were here, they put all their effort on it, and they got to the water. Maybe it didn't go well in that 15 minutes, but maybe tomorrow it will be better, right? So I think, from the perspective of performance or motivation, it's not much different. You could see good education background and a lot of will and motivation to work well in the water. And I believe there will be no issue for the Asian team to come to Europe and beat the best European team that we have there.
Well, you have been going to a lot of these competitions in different regions. What are your thoughts on that? You have been going and seeing the competitions and interacting with researchers from all over the world. So what are your thoughts?
Yeah, I've done in fact, I have a PhD student who's doing extremely well in China. He's got, I think, 4 labs now, so he's got an unbelievable staff. I have been around the world a number of times to see these competitions and work with other researchers in different countries and whatnot. And what I found is that in terms of this competition type area, that there was no difference intellectually. So I could talk to somebody from, I don't know, Malaysia, and they know all about the control systems and so forth. So that's never been the problem. There was an economic disparity for a long period. That was really the difference between the competitions. So, but now I'm seeing that's actually, you guys are working through that in Asia, and actually some of them, there's a full ring laser gyro in the Russian vehicle, there's a full scanning sonar on one of the other teams. So you're making your way through this as the instruments get cheaper and your access to them is going up. The competition here in Singapore in particular is a highlight, and Asia is really coming on. So I think there's no intellectual difference, that's for sure. So it's just about resources.
Richard, do you see any difference between the regions from an industry perspective in terms of where technology comes from, or where you have markets, or where there are job opportunities in this area?
Very simply, no. The industry's global, that's for sure. You know, if we take oil and gas, which is one segment of the industry, there's oil and gas in North America, predominantly Gulf of Mexico. There's oil and gas in South America, predominantly Rio de Janeiro, but Venezuela, Argentina, even Peru. There's oil and gas in Europe, in the North Sea. There's gas in the Mediterranean. There's oil and gas off the west coast of Africa. There's the world's third largest oil and gas company, Petronas, just a little way away from here. There's a massive oil and gas field off the west coast of Australia. So no, from an industrial perspective, the need for this technology, the need for these developments, and the people is consistent around the world. Now, by some quirk of history, some of the companies that operate in those areas may be from Europe or from the USA, but we're seeing that change. We're seeing more and more local homegrown survey operators, survey companies, exploration companies, and more investment from the oil and gas majors in regional partners that enables employment and development in the different regions around the world. So from an industrial perspective, there is absolutely no reason why you guys can't go on to have a career either here in Asia or in Europe or in South America or in the USA.
Well, you briefly touched upon the fact that there has been an economic disparity, at least in the past, in some of these competitions. And one of the questions that I do have on top of the list here is, how do you build low-cost underwater robots? Do you have any tips for people to deal with the economic disparity that might be there?
Well, I've seen some interesting things over the time. So you have to get creative. So you can go out and ask for sponsorships and so forth. But one of the best ones I ever saw was a team, and they had a young lady, and her job was to get money. That was her sole purpose on the team. She was a marketing major at the university, and so they brought her in to be a part of the team and collect funds. She took one of the engineers and went to a pizza joint. She had him covered in 5%, I think it was 5% off coupons outside the pizza joint. For every coupon turned in, they got money. So he was the billboard out front. So that was a bit creative, and people loved it, and they made a lot of money. I think they made $1,500 doing that or something, just that one idea. So it's about the economics of things, and I should also couch this in a different way. Even in industry, where I work in Bari, we're always fighting with money. The resources of manpower and dollars is a constant battle in industry and governments and research. Research probably has it harder than most others. So it's one of those things that's always going to be an issue. But I'm seeing things like in Asia where your equipment is coming up and so forth. So creativity is one way to get around it, and being aggressive about getting out there. Not too aggressive, so you're rude, but being out there and hustling the bushes a bit. And people want to help you, by the way. You find that they may not always have the money, but they may have there was one team I know that went to a research lab, and they were allowed to go through a parts area that was all that leftover stuff. So they got a DBL, they had an IMU. They were the last generation ones, but they worked. They got it for free. So if you know somebody at the university is doing some work, a lot of times they have old equipment that they've moved on from, and it's just sitting on a shelf. And so I've even got equipment from the Navy right now at my lab, and they loaned it to me, but they'll never come get it. And so it's actually at the university in a vehicle. It's been running for 10 years now on a loan. So, and that's how it goes. So you just have to sort of knock on doors, make some friends. That's what I was telling you about earlier, about the links and the connections you make here. You'll get ideas about all of this from each other, but somebody will say, hey, this guy, call this guy Blue Robotics or something like that, and he'll help you out or something. So people want to help you.
Also, you have been involved in the European competitions for a while. Have you seen any innovative solutions in terms of things that drive costs down for teams that come to your competition?
With some idea, I have a very funny example. So, one year we had a task that the teams we had to turn the valve, and one team to turn the valve. It's also an AV competition, so there's no remote controller to do that. They didn't have a manipulator, they didn't have the money for it. So one team did basically a hook, and they pushed it with that hook. Another team went even lower cost. They used a broomstick. They had a camera on the top of it, and you detect the valve, and then just go with the vehicle and push forward the valve until it turns 90 degrees with the broom. So we see a lot of low-cost solutions coming in these competitions, but I want to add on what Bill said. Another option that you have also, and we have tried to do this in Europe for the past years, is to provide to the teams materials and instruments sometimes to loan for free, or get companies involved that loan or even give beta products to test at the competition, and also get feedback from the teams how the product is working. And with that, we managed even to bring new teams. There's at least 2 examples that we loaned the platform for 2 years in a row, and now the teams build their own platform and come into competitions. And one of them didn't even do marine robotics before, so that's a way of increasing participation and bringing teams that maybe didn't have the resources or even the experience. But of course, we have a lot of low-cost solutions, Broom or other funny ones. There's a lot of teams that do not have, of course, the resources, and they try to do with what they have.
Kelly, have you seen anything that you would like to bring up in terms of low-cost solutions over the different competitions that you've been working with?
I am just struck by teams that show up that have an extensive research network at their university, extensive investment in the research that's being done, and they get in the pool and are not prepared to perform. And I have seen teams come in with a plastic box from a company called Tupperware in the United States that has home sales to moms, and be able to do the basic task and have very limited, being a middle school or a high school team, and being able to think outside of what solutions somebody else has already thought of, and be constrained by a budget of less than $100, and be able to compete. So I've seen that. I've also seen teams come in and have no idea that their solution is so innovative that all the members from industry who are part of the exhibition of the competition are swarming around their tent saying, you need to patent this. Nobody's thought of this so far. So I've seen that range of performance at a very low dollar. So not all resources are funding. Do not discount the fact that your brain power is an incredible resource. And it's an intangible resource, but it can't be discounted.
I think some of the cost drivers for a lot of these vehicles, it's either localization, navigation, or communications in some cases. With SAUVC, communications has not been a big issue, mainly because they're meant to be autonomous vehicles, and once they're in water, they don't communicate. But let's say down the road we have competitions, and you are already having some of the European competitions or the US competitions where you're required to communicate between different assets. If it's above ground, there are plenty of options available. Underwater, the options are more limited and often pursued as expensive. Like we had a question this morning about acoustic comms versus laser comms. So do you have thoughts on low-cost underwater communication solutions that students might have access to if they were introduced in competitions like this in Europe?
If you have a swimming pool like this where the water is very clear, then you do have some options. You could create, there's a system that Woods Hole is putting out, which I think could be imitated by students quite easily. They're using blue LEDs, and so they have a little sphere of these LEDs, and then they have a receiver on the other side, and then that one has a blue sphere and a receiver on the other side, and so you can you essentially have to do a burst that's sort of non-directional with the light. And so you have to think about how you're setting up your mission and whatnot. But LEDs are dirt cheap. Making them pulse a certain way is not very difficult for any of you guys. And having a photodiode on the other side to pick it up is not tough. So you could probably do something like that. There's a lot of other things when you start getting into your career with occluded water, meaning it's murky. So there's difference polarization and some other really cool techniques that I always like. They're just fun to look at and figure out how they work. But and it depends what range you want to go. So earlier somebody asked about using lasers, and I pointed out to Gabriel that you can do electromagnetic communication, but you're only going to get about 6 bits per second or something. It's just enough information to say launch missiles while it is. So there's options. I know people are working on skin effect, so they're putting radio waves in and using skin effect on the bottom or the surface of the water. So there's things like that. But I think for you as a student and whatnot, if you want to really do it optically, I would say something like the LED arrays in a sphere, half a semi-spheres thing. It's probably not out of the realm of doing it.
We were doing some research on how to use sound. You are a bit limited, but and I'm not talking, the Pinger acoustic transmission, but using motor modulation to communicate between two vehicles, and so you can send a signal from your propulsion unit to the other vehicle. I mean that takes working out some code, basically between the two vehicles. There was a very low-cost solution at ERL and PMDino. Was the professor from Newcastle? Yeah, you can talk about it.
Well, I didn't want to make names, but yes. There was this solution from the University of Newcastle. In that case, it's a spin-off from the university. They provided a better product to the teams to actually track it on real time. So it was actually helping the judges also, because the judges could see in real time on the screen where the vehicle was. So that's one option, is like to ask companies to provide to teams, even just one or two individual teams related among themselves, one acoustic modem to test at the competition. In the past, we were using in SAUVC, we were giving the same. We had an acoustic modem, and we gave the protocol and one of the teams. They had to use that one, so the judges could also see the messages in the computer. If they wanted another one, then it's up to them to get the modem and invest it. But yes, there are some lower solutions.
We actually used that system. We lost a fish during the competition, and fortunately, we were running some experiments, so we knew where we lost it, and we were able then to use the system to tell the diver where to go and get the vehicle that was down. Yeah.
So we employ a variety of predominantly acoustic systems on our autonomous underwater vehicles, but we're talking about ranges potentially, slant ranges of 10,000 meters. Most of our deep water AUVs are rated to 6,000 meters, and unless you're following it around with a boat directly overhead, you're going to have some increased slant range. We don't need massive amounts of bandwidth. If you look at something like the HiPAP 102 system, so that's a low frequency, 10 or 12 kilohertz system. It's got about 13 kilometer range. The HiPAP transducer sits on the boat. If I give you an impression of size, the transducer itself is 50 centimeter diameter. It's a half sphere, weighs a couple of 100 kilograms. The transceiver cabinet is about a meter tall and 3/4 of a meter wide, 3/4 of a meter deep, and weighs a couple of 100 kilograms. So it's big, it's heavy, but it has to generate a lot of power to put that signal into the water. And then the transponders we put on the vehicles are relatively small. We use something called Symbol Protocol, which is our proprietary digital protocols for communications. To give you an idea, over those 10,000 meter ranges, we're sending probably somewhere in the region of 2,000 bits per second consistently. We send a position update to the AUV, and then we get telemetry back, and then we also get a small amount of compressed sensor data, acoustic sensor data, so side scan, sonar, multi-beam echo sounder, back from the AUV. It's not sufficient to see anything particular in the water or see any objects of interest, but what it is good enough for is saying, yes, I'm on, yes, I'm working, yes, I've got the right settings, that type of things. To give you an idea of how not low cost it is, the HIPAP system, the topside HIPAP system alone is about $250,000. So it's expensive, but it's incredibly capable. Now on the other side of things, we're involved in a project called eLoom that I'm going to show you later on, which is a subsea resident robot for inspection, maintenance and repair for oil and gas and some other applications. And now in those environments, it doesn't have a tether, but oil and gas is a very conservative industry. You cannot interact with a structure on an oil field without direct operator control. So whether you have a tether or not, it's kind of irrelevant. You have to have some level of communication with that vehicle. So we're employing a very short range, about 30 or 40 meters, because that's all we need, but high frequency, high bandwidth acoustic comms, where we're getting 25 frames a second video, 720p video. We're getting real-time control of the vehicle, and we can physically swim the vehicle in, connect to a valve, and turn it, all through direct operator control. Now the benefit of having that type of system connected to a subsea network in an oil field is it means your operators don't need to be on a ship directly above the oil field. They could be, you could operate a vehicle from here in Singapore that's working in the Gulf of Mexico.
I don't know why I didn't think of this first. Another cheap solution for this kind of activity for communications is Wi-Fi. You're not that far away, so you can boost your signal to a touch out of a, you used to say Radio Shack, but they're out of business. We've done it at Embari on a number of things, and you get a lot of errors and packets and whatnot, but you actually can communicate at some reduced rate, but it's a heck of a lot more than anything acoustic will do within the range of this pool, and you also don't get multi-beam problems in it. So that's something for competitions only, probably. But get into a swimming pool and try it out, and send some images or something across, and you'll see that you can probably get pretty far enough to have two vehicles work. Do pretty well.
So, changing the topic a little bit, when we went around looking at many of the team robots, there are several teams around who have been using ROS for their vehicles, but there are quite a few teams who are using other things. So they have Arduino-based systems, there were Python-based systems, and so on. ROS, however, has been making quite a lot of inroads into many different vehicles around the world. So, what are your thoughts about ROS's operating system and what its role is in marine robotics?
Well, we saw many teams that had ROS. I think the majority did not have ROS here. Some of them were using other software, as you said, but even without ROS, they were using deep learning for some tasks. So it's not that it's mandatory for a competition like this to use ROS. It gets you maybe more modular code that you can use to extend for other competitions and for your future. And it's also probably easier to reuse for the next students of next year, so it's actually a good idea to use it. Of course, if you are still starting, it's your first year, it's not mandatory, or it's not that you need to use ROS to start with. You might be having other travels, you might be focused on hardware travels or mechanics or electronics. So go for that when maybe you are a bit more mature and you have the time to focus on something like that. It's still, I think, maybe it didn't win yet on marine robotics. There's still loose IVP. It's widely used. I'm not sure which one will be more used in the future. ROS is getting more and more track, especially in the ground domain and the aerial domain. In marine robotics, I don't know yet what will be more useful.
Very briefly, I can comment on that. So we own a company called Hydroid. We're based in the USA. They build vehicles for defence, autonomous underwater vehicles for defence. And about 2 years ago, they swapped to ROS. Our in-situ navigation processing for all of our AUVs, whether they're commercial, defence or academic, is on a ROS platform.
So we will be using ROS for the Maritime Robotics Virtual Challenge. And you are not required to use it. The protocol, you could use Moose, you could use, whatever you have, but that's what we're going to be interfacing with. We find that it's an open environment that you should be feeding back, if you are using ROS, any new developments you have. And that it raises the level of performance of all the community. And so I encourage new teams to start there. There are some teams that have 20 or more years of legacy code, and it's really hard for them to move on to that. But they have a good infrastructure in place at their university and a good documentation for corporate knowledge passing it on. If you don't think you have that, ROS is a pretty good solution.
ROS is an open source community type situation, and that's what's made it popular, particularly as a backseat driver. A lot of the vehicle systems are closed in terms of their software, so ROS has been, in my experience, has been a workaround for a lot of that in competitions. We are using it also at Embari and so forth. And it's probably going to be around, and Moose will probably go away in the not too distant future, is my guess. ROS will take over. But I would caution, it's like Baskin Robbins, this is the flavor of the month, so keep your mind open. There will be something else coming along. I remember when I started out, Fortran was the language, then it became PL1, then it became, I can't remember, there's been so many of them, C, C++, Python. So ROS is just one in a step, and then somebody's going to come along and it'll become popular. But it's actually very useful right now because the modules, you can get them, and it gets you a fast track to get moving. So it's got a lot of benefits, but just remember that as your career as an engineer, it won't be around forever.
So, talking about flavor of the month, things go up and down. Currently, one of the big buzzwords in the industry is artificial intelligence and deep learning and so on. What do you think is the role of those in marine robotics?
I might be a bit polemic on this. So I think that artificial intelligence can be used in a huge number of applications. When you're speaking about real-time control of a vehicle, it might not be the way you want to do it. For instance, I will do parallel with autonomous driving. There's a company in Singapore that is doing control the hard way. They don't want to use just artificial intelligence like other companies are doing. I believe that's a good approach if you want to have transparency of code, be in control of what you are doing, that you want to know what you're doing. If you're speaking about shape recognition or detecting the poles with a deep learning neural network, that's okay, of course. But for critical missions, you might not want to just use that, at least until you understand well the technology and get a grasp of it. Because doing the way of just some magic, not to know what's happening, it's not even a good thing for students to follow that path because they won't be learning much, right? And you'll decrease the thinking, critical thinking for the students.
So I get asked this a lot. I go to a lot of trade shows, a lot of conferences, and there's always a session at a conference about marine robotics, about artificial intelligence and analytics for autonomous platforms. And one of the questions that's always asked in the audience is, how can we allow companies to use things like AI because it's not necessarily predictable? And I always give the same answer. We do not use AI for control systems. We use deep learning, as Fausto said, we use deep learning, machine vision, whatever term you want to use it, to process data on board and provide feedback to the control system. But our control system is very deterministic, it's very predictable. So we have, on board all of our EUVs, we have a fairly complex, hierarchical, condition-based decision matrix. If I see this, I will do that. If it's this time or I've reached that location, I move on to do that. Now, by all means, we can feed into that, information generated from deep learning, whether it's optical image processing, whether it's sonar processing. We've done on our vehicles, for example, we've done automatic target recognition and identifying objects of interest to feed that back into the guidance system to go and photograph something on the seabed. But that's, that's the limit of it. Where it gets fed back into our guidance system, into our control system, that's the end of the use of any AI in air quotes.
So deep learning is really just multiple layers. So, anything we're doing is multi-layer. But as far as AI, what I see is that we're not truly doing anything that's AI. It is the combinatorial complexity that we introduce by the multiple layers. So, yeah, AI is not there.
Some of you were here a few years ago when I gave a talk on the sliding scale of autonomy and all the way to AI. So human beings have created AI. You know the answer, right? Teenagers. So that's the only AI out there. You train them up through their life, deep learning, if you will. Then you let them go, and they disappoint you. So, but in reality, we're a long way in robotics from that because we have goals that are preset, and the robot doesn't feel good. We don't care. So it's going to go to school and do what it's going to do. So I wouldn't worry too much about AI for a long time.
I think that's the control systems and intelligence, whether it's artificial or we give them a set of rules for the vehicles to work. As it goes on increasing, we could potentially see more of these vehicles staying in water longer time and doing things. So Richard talked about having some resident vehicles in the water. But one of the trickiest areas in that is the energy systems. Where does the energy for these vehicles come from? So is there any research that you know that's happening in developing energy systems or harvesting energy from the ocean so that the vehicles can stay down much longer?
Yeah, certainly. So I mentioned earlier, we're involved in a program where we've got a subsea resident vehicle for inspection, maintenance, and repair. And in this particular example, we're going to be using the network that already exists on an oil field for communication and energy. Now, it's not particularly high voltage, it's not particularly high current, but it's enough for us to trickle charge capacitors to then charge batteries on the vehicle. The challenge then becomes, what happens if we want to move this to what's known in the commercial world as a brownfield site, an existing oil and gas field that doesn't have that network? What do we do there? How do we charge these vehicles? Because we might be talking about having a resident capability for maybe 6 months at a time before it needs servicing, before it needs recovery. So from a commercial aspect, we've actually gone beyond research into production. There's a company called OPT, Ocean Power Technologies, just as an example of one of many. They build a wave buoy that generates electricity. It also has RF and satellite communications on board. So it has a central piston that moves up and down and a float collar that moves against it, and they use that to generate electricity. Again, low current, but enough to feed a bank of capacitors or batteries for us to then charge the vehicles.
Sorry. Well, energy's always been the real, particularly in autonomous systems, it's the driver. So it's going to be for a long time. I was approached by a government agency at one point about trying to scavenge hydrates because there's hydrates all around the world at the continental shelf, and they're energy-rich methane type systems. There's a lot of fuel cell work going on, but because of the toxic chemicals and whatnot in terms of being explosive, the byproducts are a big problem. So people don't like those. There's all kinds of things going on, but we're still a long way away from a big breakthrough as far as I can tell. When they say there's a new breakthrough in batteries, when you actually look at it, this usually is a very incremental increase. It's not going to revolutionize things. So my guess is that for something like a brownfield, if I were going to do it, what I would do is have packs that I could just drop on the bottom. The robot would locate it, just swap out a pack, and then another pack would be released, come to the surface and recharge or something like that. So you just literally just dump them off the back of a ship, go out and leave about 20 or 30 of them. They both just be there, the sulfuriant, so it's easy for the vehicle to land on, that kind of thing. That would be my first probably thought.
So the answer is yes, there are many efforts underway, research efforts looking at the S&T. One such effort was an SBIR effort that looked at energy harvesting from thermal vents. So don't know where that is right now. Maybe Mr. Resner has any clues on that. But the U.S. Navy and DARPA-E are looking at this very hard. Don't have any solutions to offer you for competitions, but it is a challenge for everybody.
Well, one thing that would be very nice in the long future is robots that will eat plastic and get energy from that, right? You solve two problems in one.
Well, speaking of that, actually, there is a company in Singapore who approached me recently wanting to build a ship which was going to eat plastics and propel the ship around. I don't know how far they have gotten, but it is something that some people are already trying.
Yeah, earlier you heard Tom Curtin's name mentioned. Tom's been a very good buddy of mine since I got in this business. And we've had discussions about how to bring some liveliness to these competitions. He had an idea that I think is hilarious, but he wants to give you a cup of sugar as your energy source. So you're, but and then you take that sugar and you can do anything you want with it to get the longest endurance. So, but that's your starting point is tablespoon. I thought it was a half a cup or something of sugar. But so if you guys are interested in trying something like that as a challenge, let us know, because he thinks it's a hoop that you would have to. You don't have to really do a task. It's about who can go the furthest on that energy, that bit of energy.
Well, the other big problem, at least in this region of the world, for persistent autonomy is biofouling. Having these vehicles sit in the water, well, biofouling as well as corrosion. Do you have tips for students who might want to graduate beyond the swimming pool into the ocean environment and have vehicles for a reasonable amount of time? What should they do about biofouling and corrosion?
Yeah, I mean, Bill joked, go deep, get away from it, that's number one. Be careful with the selection of your materials. Aluminum housings with stainless steel screws, put it in the water where there's biofouling, come back 6 weeks later and you'll be left with stainless steel screws and no aluminum housings. So be careful with your material choices. And then, for one of the programs we're working on, which is 300 to 500 meters depth, in an area where there is some biofouling. We're just below it, but we're being quite careful with how we actually treat these vehicles. So as the vehicle docks and leaves again, there's a cleaning brush to help get rid of some of the materials that build up.
I don't have any solution. We have a permanent acoustic network deployed, and every 3 months at most, we have to recover almost everything to clean it. Maybe robots to clean biofouling would be an option.
Yeah, that's the option we're pursuing. The research we're doing is not the longer term, but we do have a lot of research active on biofouling and corrosion control for ships in general. So it's pervasive, ubiquitous problem in the maritime environments. So what makes it so challenging. So energy, power and energy is a problem, system reliability is a problem, and that's all part of system reliability.
Biofouling, where I work in Monterey Bay, is extremely bad. It's really terrible. But there are things you can do that if you're talking about your future. As a competition, you wouldn't do any of these things. But the Navy has been working on things like sputtered PET. So they essentially make a surface that animals can't hook to. So they can only get so long and they just fall off. They just can't stick on it with the currents or anything. It works pretty well, but it's not a complete solution. We've also done things with actively charging the surface. So you can run electricity through it and cause them to not attach. But then you've got other problems. You've got to watch your materials really badly. And so those kinds of systems are, if you get a ground loop or anything like that, it destroys itself because you've got an active hull. So it's a real big problem. There's people who make a career out of this alone. So.
Well, we briefly talked about the idea that maybe some of these vehicles could eat plastics and could solve some of the marine plastic problems. We talked about biofouling, and some of the solutions for biofouling may be polluting, maybe other solutions are non-polluting. So at the end of the day, what do you think marine robotics is going to do for the oceans? Are we going to help reduce the pollution in the ocean or solve some of the problems? Are we going to be increasing some of these problems over time?
I think robotics in the environmental realm are probably marine robotics are going to be a big player. I also think the same is going to happen for fisheries. I'm consulting with 2 companies on how to do some work so that we're spending a lot less energy and a lot less pollution and fewer entanglements and things like that. So I believe the technology that you guys are going to create in the future is going to be a big, big player in these things. The plastics problem is a really interesting one, and I'm only getting into the early part of it myself. But it's kind of an odd thing because the vehicles we usually send out there are plastic. So if you're using a plastic vehicle to go get plastic, it's kind of an odd thought. But yeah, I was talking with Richard the other day about this. We have problems today based on what happened in the past, and we put these value systems on today about how people were so bad or weren't thinking. That's not really how it comes about. At the time, people thought they were doing the right thing, trying to solve problems that they were faced with. And then these unintended consequences come out of that. And that's the problem we deal with. And the solutions that we come up with are probably going to cause unintended consequences. So be ready for that. But in America, as a private, I don't know about the Navy, but as a privateer, a boat or fisherman or whatever, you cannot get toxic chemicals for your hull anymore. So there is no copper paint anymore, anything like that. It's not allowed. You can't even get it. You can't find it in the country. So there's steps being taken on all these fronts, and I think the things that you guys create in the future are going to be the next step in solving that. I'm particularly dealing with microplastics, which I'll talk about later, and that's a real problem.
So I like your idea of unintended consequences. I think just as we have a satellite debris field or a space debris field, if we are not careful, we will have, a littering of lost vehicles at the ocean bottom, or even adding to the pile of plastic islands. So that is a real concern.
Well, I hope the balance will be positive, that we have less pollution than what we are creating, but we should not underestimate also the fact that with marine robotics you can actually estimate better climate change and get a better ocean monitoring. So you have an impact beyond the plastic that you're putting on the oceans. I think that's a very big positive impact that we should consider.
I'll second Faust on that one. So we know very, very little about the oceans and the seafloor. From a hydrographic perspective, from a mapping perspective, if we were to go out with all of the survey boats around on the planet today, with all of the multi-beam echo sounders on the planet today, it would take us about 200 years to actually survey the bits that haven't been done yet. To give you a scale of the problem. From an oceanographic perspective, it's even worse. We have tiny singular dots of information from various places. We really don't have a holistic model of how the ocean works and what we're doing to it. And as a population, I think it's pretty clear that we are having a negative effect on our environment. Some of that is being caused by what we're putting into the ocean, but don't forget a great deal of it is probably also being caused by what we're doing on the land and in the atmosphere. So I had a discussion with somebody we all know, Justin Manley, a couple of weeks ago. Justin's, he likes to put out thought pieces in the marine robotics realm. And he has been asked recently about writing a piece about how do we solve the oceans? How do we make the oceans better? And actually, perhaps the place to start with making the oceans better is by controlling what we put in the atmosphere on the surface.
Great. I think we have a few more minutes left, so I'm going to open the questions for the floor to ask any questions before we end the session. So, any questions? Right, then I can take a few more questions from the list that we have here. So one of the questions out there was, will humans be forced to live in underwater cities in the future?
I love the sunshine, I hope not.
I agree with Kelly. I don't think we're going to be forced to live in undersea cities. I think there are a lot of people who would like to. The Captain Nemo thing and all that's pretty cool. I think there'd be a lot more technology in terms of managing resources and so forth subsea that'll turn around with a lot of type things. But if you look at the economics of having people in the ocean, that would probably say that it's not going to happen. It's extremely expensive to put people on a ship even in the ocean. And so if you, right now, the container ships, they're all working towards complete automation. So once they've loaded up, they get them out of the harbor, there's nobody on that ship. It's going to go all the way from Japan to England, being driven by somebody on shore, go have a cup of coffee and whatnot. The autonomy, the entire field that you guys are working at here, is all about getting people out of the loop. That's why I've been doing it for 30 years. It's cheaper, and it's more reliable in the sense of we're getting to that point where you can depend on it and not lose the vehicles all the time. I've actually parked them for a few weeks, but never lost one. So, yeah, I don't see as living in the ocean by need. I see it as more hotels or that kind of thing. In fact, I think there is a hotel somewhere out here. Yeah. So it's more of a Disneyland kind of an event.
So I think it will be for need, but more and more hotels will come up like that, and we also have private submarines with windows for luxury tourism, like space. So it might eventually happen that with time it gets more affordable, and people might actually start looking into that as an unintended consequence. So I cannot predict that, but for sure there will be more and more tourism in this area. Hopefully it won't force us to go living in the water and also sunshine.
Yes. I don't know about force, but it would certainly be nice to increase the awareness that there is a whole world underwater, which people don't realize because we don't see most of the things that are underwater.
I don't know, now there's popular parks where you can have a scuba gear and walk underwater. So for people that don't have diving equipment or are not using to dive, you have a cable up to the surface and you just walk in an underwater park. So that goes in that direction.
In fact, if to answer that question, you can look at history, right? The Dutch have claimed back what was under the sea by putting up walls and pumping it out. New Orleans is going to do the same thing. They're going to put up bigger walls. They're not going to move. It's actually below sea level already, which is why they're in trouble. So we're probably going to lose certain amounts of land as the sea level rises a bit and whatnot. People will move away from it, but only in the non-built up areas. So like certain coasts of Florida or whatever. But, the world is always going to change. I did a lot of work in CO2, and I had people always ask me about the planet, if it's going to be okay, and it's going to be just fine. Not so much.
The roaches will survive, but we won't. I think anything thinking along those lines would be rather apocalyptic. And there have been a couple of disastrous movies made about, Waterworld, and I think there was even an Australian television show where they lived underwater, but they could come up, I guess. So, yeah. And submarines are quite tight-living. So if you know a Navy submariner, you might ask them about that experience. I don't think it's pleasurable. It would be forced.
So I guess some of the data centers are now being built underwater. Yeah.
I have nothing to say on that subject.
All right, I think I'm going to close the session with this, but if any of you have any closing remarks before we break for lunch.
Yeah, apart from thank you, I guess I have one thing to say, and it kind of follows the theme of the competition. So you were set 3 or 4 different tasks in the competition and have to build vehicles to achieve those, and how you do it is completely up to you. As you move forward in your careers, actually don't just build something for the sake of building a piece of technology. Try and solve a problem. Identify a problem, identify a need. Whether it's a commercial need, a military need, or an environmental need, identify a problem and try and solve it. Because that's the way that you'll actually get your technology out there and used.
Richard just struck a chord with me here. For all of you who are graduating and getting into the field of engineering and so forth, as a manager, and I've managed people for a long time, back in the military industrial complex and whatnot, and the biggest error I see from engineers is point solutions. So they got a set of requirements, they got a thing in their head and say, I've got to go this way, and they start drawing, or start laying out their circuit boards, or whatever. Engineering is not drafting, and it's not making a PCB. That's the product you're sending out once you've already done the engineering. The engineering is the thought process before you get there. So your engineering is actually all done before you put pencil to paper, except for calculations, or modeling or whatever, to settle your trade studies. Engineering is always a compromise. You don't get perfect solutions. So you take your requirements, put them into a system spec kind of a model, and then you think about how you want to do that, and you come up with multiple ideas, and then you trade them against each other to come out with the best compromise. And then you start putting your stuff to paper. You'd be very successful that way, and the people who are watching you work, giving you promotions and money, are going to really appreciate it. The guy who runs straight to the table and says, I got this, is always a disaster.
Follow up on this, so always do what you like in your career. Don't take just a job for the paycheck or something, because in the long run, it will make you miserable. So if you don't like something, don't be afraid to change and to take risks. I think that's the biggest career advice I can give you.
Exactly what Fausto said. Follow your dreams. I did, and I really think I have the best job, at least in the building where I work, but I think I have the best job in the world. And I love what I do. I get up every day, and it's not a job if you love it. But on the other hand, you're an engineer, you're a creator. Create that pathway for yourself. It's an amazing adventure. Good luck.
Thank you. Please join me in thanking the panelists for great insights.